According to estimates, about 50% of plastic waste from urban sources has a higher density than seawater, causing it to settle on the seabed, be carried by deep-sea currents, and accumulate in trenches and depressions. Microplastics have even been detected at the deepest point of the ocean, the bottom of the Mariana Trench. In reality, it is not the ocean surface but the deep-sea floor that serves as the primary repository for microplastic debris. Consequently, the entire seabed is gradually being covered with a plastic layer. However, data on ocean pollution by microplastics are underestimated, and the reality is far worse. Not everyone has access to very sophisticated and expensive instruments and sampling tools, explains Melanie Bergman, a biologist at the Alfred Wegener Institute in Germany. In her opinion, as much as 90% of marine microplastic particles may be missed by standard sampling techniques because they're too small to be detected. The highest concentration of plastic is in garbage patch zones. These oceanic dumps act like factories for the continuous production of microplastics. Similar to how a virus spreads through the bloodstream, microplastics are dispersed throughout the global ocean system by currents. Since oceanic gyres are present in all the world's oceans, microplastics accumulation is occurring on a global scale. Even a remote and uninhabited region like the Arctic is no exception. Ice core studies have shown that microplastic pollution levels in the Arctic Ocean are 2 orders of magnitude, 100 times, greater than those in the Pacific Gyre. In addition to the 2 layers of pollution, the surface and the bottom layers, the concentration of microplastics significantly increases in another area, the thermocline. This is the layer of water where temperature changes sharply with depth. Due to high-density gradients in this layer, micro and nanoplastics become trapped, remaining suspended there for extended periods. Picture the ocean as a layered cake, where each layer has distinct temperature and density characteristics. Microplastics tend to accumulate at the boundaries between these layers. Additionally, microplastics can also be transported in the ocean by marine organisms that ingest, digest, and excrete plastic particles.